Hey everyone, today we're going to be talking about bond line structures, specifically adding implicit hydrogens and lone pairs. So just to recap really quickly, in a bond line structure, each vertex, so a bend or a corner, is a carbon. So if we look at this molecule here, we're going to have 1, 2, 3, 4 carbons in this molecule. Now, for implicit hydrogens, we're only going to need to add hydrogens onto carbons. Other atoms, they're usually like oxygen or nitrogen, they must show the hydrogens that they are bonded to. In carbons, you don't need to show the hydrogens it's bonded to. So for a carbon, we want 4 bonds in total if there are no charges. So starting with the molecule on the left, if we look at this bottom carbon right here, right now it's only shown to be bonded to another carbon. But it needs to have 4 bonds in total because it has no charge. So we can put in 3 hydrogen bonds. And now the carbon has its full octet. So these 3 hydrogen bonds, they were always there. It's just that we're explicitly showing it now. The same goes for the bottom carbon on the right. It's still only shown to be only bonded to one carbon above. So we're going to have to add in 3 hydrogens just so that it has 4 bonds in total. Now, this carbon in the middle right here, notice how it has a positive formal charge. In this case, the carbon can have 3 bonds. So this carbon is not going to have any additional hydrogens because if we were to calculate the formal charge, it has 4 valence electrons and 3 lines around it. That gives us positive 1. So we can't, 4 minus 3 is positive 1. So we can't add any hydrogens onto this carbon. Now the carbon on the top, we get the same pattern as the 2 on the bottom. It's only connected to one other carbon right now, or at least that's shown. So we need to put in the 3 hydrogens so it has 4 bonds total. Now, if we look at the carbon or the molecule on the right, we can start with this carbon here, and we're going to see the same pattern, right? It's only connected to one other carbon. So for 4 bonds total, we add in 3 hydrogens. Same goes for the one on the top. Now, the carbon in the middle, it already has 4 bonds. So a double bond will count as 2 bonds, and a triple bond will count as 3 bonds. So this already has 1, 2, 3, 4 bonds. So this carbon is all good to go. We don't need to add any implicit hydrogens. Now this carbon on the bottom, it already has 2 bonds because it's attached to a double bond. So we're only going to need to add 2 hydrogens to it to complete its octet. So these are all the implicit hydrogens in these 2 molecules. Now moving on to implicit lone pairs, we're just going to take the atom and add as many lone pairs as we need until its formal charge matches the charge given on the structure. Most of the time, this will be enough lone pairs to complete the octet as well. So, first with this oxygen on the molecule on the left, right now it's connected with the double bond. So that means we're going to need to add 2 lone pairs, 4 electrons in total in order to complete the octet. And we can check the formal charge as well. So oxygen has 6 valence electrons, and it has 6 lines and dots around the molecule, so we subtract 6. And that's 0, which matches the molecule because the oxygen doesn't have a charge on it. If we wanted to add the implicit hydrogens onto this molecule as well, this middle carbon doesn't need any because it has 4 bonds around it. And these 2 bottom carbons are going to need 3 hydrogens each in order to have 4 bonds in total. Now, the same thing goes for the molecule on the right, at least with the implicit hydrogens. So I'm just going to go ahead and draw those in real quick. Now, for the oxygen on the top, we want a formal charge of positive 1. So if we know that oxygen has 6 valence electrons, if we want the formal charge to be 1, we know that we're going to have to add, we're going to have 5 dots and lines around the the atom. So we're already at 3 bonds, so we have 3 lines around the oxygen. So we're simply going to need to add 1 lone pair to make it 5 total lines and dots. So, and also, if we check, this completes the octet for the oxygen, because now it has a lone pair and 3 bonds on it. So that's 8 electrons to complete its octet. And it does also have a formal charge of 1. So that is an implicit lone pair for that oxygen. Now we can go over this big molecule and essentially add in all of our lone pairs and implicit hydrogens. So starting with this oxygen over here, it has 2 bonds, and we need it to have a formal charge of 0. So we're going to need 6 lines and dots in total. And it already has 2 lines, so we can add 2 lone pairs or 4 dots in order to make its formal charge 0. Looking at this nitrogen has 5 valence electrons. So we're going to need to add 1 lone pair and 2 electrons to make it a formal charge of 0, and this also finishes off the octet. The same thing applies for this nitrogen here because it has a double bond and a single bond, so that counts as 3 bonds. So adding 1 lone pair is going to make it have a formal charge of 0 and complete its octet. Same pattern goes for these 2 nitrogens, which both have a double bond and a single bond. And then for this nitrogen at the end, we're also going to need to add just 1 lone pair because it has 3 single bonds. So that way it has a full octet and formal charge of 0. Now, a lot of times, instead of showing the hydrogens attached like this for this group, it's just going to have NH2. And these two mean the same thing. So that's just something to look out for. Now, looking at our implicit hydrogens, starting on the left with this carbon, it has 2 bonds already and no formal charge, so we can go in and add 2 hydrogens. Same things goes for these 2 carbons. Now this carbon right here has 3 bonds, so we're only going to need to add in 1 more hydrogen. This carbon right here has a double bond and a single bond, counts as 3 bonds, so we're going to add in 1 more hydrogen. These 2 carbons right here have a double bond and 2 single bonds, so they don't need any additional hydrogens. This carbon right here is a double bond and single bond, so we're going to go in and add 1 more hydrogen to make it 4 bonds total. This carbon right here, a double bond and 2 single bonds, so it's all good to go. We don't need to add in any other hydrogens. Thank you so much for listening.